Let's say that we have a liter of a 5 molar solution. This big M means molarity. Molarity is a unit of concentration. So it's communicating with us about how much solute we have per unit of volume of the solution. Molarity, in particular, tells us our concentration in units of moles per liter. Molarity is always going to be moles per liter of solution. Let's figure out how many moles we have in 1 liter of our solution at this concentration. We can solve that in one of 2 ways. The first is solving this equation for moles, or we can also use our concentration as a conversion factor. Let's take a look at solving our equation. Let's call that method 1. So here's our blank equation. Molarity is always going to be about moles per liter. And let's plug in the variables that we know. We know our molarity. It's 5 molar. We're going to be looking for moles, so that's X. And we know that we have 1 liter of solution. So to solve for X, we're going to multiply both sides by 1 liter. We see that that multiplication gives us 5 moles of solute. Now you might be looking at your units and thinking, how do you get moles out of those 2 units? Anytime that you see big M, you can always replace that with moles over liters, because molarity means moles per liter. And when you separate out big M into moles per liter, you can more clearly see that your unit of liters cancels, leaving you with moles. When you're using this method, it is critical that you remember that molarity is always moles per liter. So if you're ever given your volume in something other than liters, you would first need to convert your volume into liters. Let's look at method 2. Using molarity as a conversion factor. Molarity is always going to be moles per liter, which we can use as a conversion factor. It's telling us that for every liter of solution, I'm going to have 5 moles of my solute. So now I have a relationship. So let's use this relationship as a conversion factor to figure out how many moles of solute are in this volume. Okay. How many moles is contained in 1 liter of solution at this concentration, which is telling me that for every liter of solution, I have 5 moles of solute. Multiply everything on the top, divide by everything on the bottom. We're left with moles, which is what we wanted. We can see that we have 5 moles of solute contained in this volume. Either way works. But then, if we were to add some solvent. Let's say that we added a liter of water. Okay. So our solution that started like this now looks like this. The volume of our solution has changed. Okay. So let's figure out what our new volume is. Let's call our new volume V2. Let's find V2. So V2 is going to be equal to the volume that we started with. So we started with 1 liter of solution, and then we added more water to produce our new solution. Okay, so we started with 1 liter of solution, and then we added a liter of solvent. So now we have a new volume. Well, if our volume changed, so is our concentration. Our concentration is always going to be amount of solute per volume of solution. And since our volume has changed, so is our concentration. So let's find our new concentration. Let's find our new molarity. Molarity is always going to be moles per liter of solution. Okay. We still have 5 moles of our solute. We only added water. We didn't add any more green dots. So going from here to here, we still have 5 green dots. We did not add any solute. Okay. So we still have 5 moles of solute in this solution. But now we have a new volume. So now instead of having 5 moles per 1 liter, now we have 5 moles in 2 liters. So our new concentration is 2.5 molar. So notice that our concentration dropped from 5 molar to 2.5 molar because we changed the volume of our solution by adding more solvent to it. The number of moles in a dilution doesn't change. It remains constant. And because of that, we have a relationship between one solution and another in a dilution. And we can often refer to that as our dilution equation. So let's take a look. Let's say we have one solution. Okay. Solution 1. Its molarity is going to be equal to the number of moles of solute in that solution per liter of solution. And our second solution its concentration in molarity is going to be equal to the moles of your solute in that solution per liter of that solution. Let's solve both of these for moles. So we are going to multiply both sides by L here. Okay. So for each of these solutions, the concentration in molarity times the volume of that solution in liters is going to give me moles of solute in that solution for both of them. Well, if the number of moles in my first solution is the same as the number of moles in my second solution, which is the case in a dilution, then we can set these two equations equal to one another. So because the number of moles in my first solution equals the number of moles in my second solution in a dilution, I can set these two equations equal to one another, which is what I've done here. And then we can just hack out the middleman. And what we're left with is this, that the molarity of solution 1 times volume of solution 1 in liters equals the molarity of solution 2 times the volume of solution 2 in liters. This is our dilution equation. This is often written in a number of different ways. You may also have this written as M1 V1 equals M2 V2. You can also see this written as C1 times V1 equals C2 times V2. So C is just concentration. It also doesn't matter what your subscripts are. Okay. It doesn't matter if this is A, B, or original and final, or concentrated, dilute. It also doesn't matter which side of the arrow those labels appear on. Okay. This is a really versatile equation. It no longer matters what unit of concentration or volume you're working with when you're working with the dilution equation, because regardless, the amount of your solute in a dilution doesn't change. So it doesn't matter what units your concentration is in. It doesn't matter what units your volume is in, as long as they match on either side of that equation. Okay. If you're working with volume in milliliters, it's fine. When you use the dilution equation, then this volume unit must also be milliliters in order for things to cancel appropriately. Okay. It also doesn't matter which side of the equal sign your subscripts appear on, as long as one side of your equal sign is referring to one solution and the other side of your equal sign is referring to one solution. It's important that the concentration of one of your solutions is paired with the volume of that same solution. Okay. So when you're working with a dilution equation, your units of concentration must match, your units of volume must match, regardless of what you work. But just remember that if you are solving this kind of equation, molarity itself is always going to be moles per liter.